In any place where it's a view of the lake and the water. My favorite spot of all, though, is at the end of Lucerne. There's a rock, and I call it Habeha, which means big rock by the water, because Habe means rock and Ha means water. So I just constructed that name out of my language to call it that. So I call that rock that, and I pray by it, and I sit there. And it's interesting because that's the same rock that in high school we stood on and took a baseball picture of my freshman year. Pretty cool. But I love the area. You know, it's beautiful, and you know, hopefully we get those tules back over there, because I know that that's an area where they don't have it. But you know, I just know that it's special. It's a special place for me.
Clear Lake is very unique. It's not like any other lake. So give you some perspective. Clear Lake is big. We know that. It's 120 miles of shoreline if you count all the coves, the islands, the bays. It's shallow. It's an average of like 27 feet in depth, which is very shallow, and it's very, very old. And I mean old. On the timeline, geologic terms, old. Let's look at the average lifespan of reservoirs in the United States. They're around 60, 61 years for reservoirs. So that's things like Berryessa, Folsom, Shasta Reservoir. Look at the Great Lakes region. You know, those are Great Lakes, Lake Superior, Lake Huron, Lake Erie. Those are 20,000 years old. That lake basin was formed, glaciers retreated. Clear Lake is basically a depression in the earth. There's some springs from heavy thermal and volcanic and geothermal activity. There's springs at the bottom that release water. And this bowl, this depression, has filled up with rainwater and stream water for about 2 million years.
California's largest natural freshwater lake, originally referred to as Hobbiton, which means big water in native Pomo. It is now known as Clear Lake.
The very first people that arrived in Lake County basically stayed in the Oaks arm of the lake and down in the Clear Lake arm of the lake for a couple of thousand years, until the population grew to the point where they needed to establish settlements all around the lakeshore. One of the main food resources and textile resources that they use was tule. Tule is, it's actually like a fabric. You know, the cell structure is like a fabric, and you can weave it, you can shred it and make it into tule mats or tule skirts or tule, shirts. You can weave it and make tule sandals. The tules float on the water, so it didn't take long for somebody to figure out, we can bundle these up and make boats out of them. So tule boats were all around the lake. Their houses were willow frameworks with thatched tule over the framework. The tule thatching is about this thick, which provides about an R9 level of insulation. And when it rains, the rain just dribbles down around the outside, so it stays nice and dry inside. In the summertime, it stays cool inside. In the wintertime, you have a fire pit in the center, and that keeps it warm all winter. So tule huts, tule houses were every village, every family had a tule house. And you can eat tules. I mean, when tule shoots first come up fresh, you can grab that shoot and pop it out of the root and peel back the base of the stem and eat it, just like a green onion. It has kind of a sweet, nutty flavor. It's really nice. The bulbs, the root itself could also be eaten. Tule is very well adapted to a lake like Clear Lake that has annual, water level changes. The water level will go down during the summer and up during the winter. And the tule bulb anchors in the bottom in the mud along the shoreline. Well, when the water level rises to a certain point, those bulbs will break loose and the tules will float around until they find the new shoreline. During a drought or low water, the water level will go down below the tule bulbs and erode the bank. So after the bank erosion, those tule bulbs will drop down onto the new shoreline. So tules are perfectly adapted to the water level changes every year in Clear Lake.
So the Rumsey scale on Clear Lake was invented by a guy named Rumsey, and he was a captain. And he's from the town called Rumsey, which is downstream near Glinda in the Capay Valley. And this Captain Rumsey identified that Clear Lake water level moved up and down in a different way than many other water bodies, and that the flow was regulated by the Grigsby Riffle. And so he identified a way of measuring the water level on a scale that reflected where the water was at its outflow point at the Grigsby Riffle in Cache Creek. So the gauge is here now at the dock at Vector Control. There was a manual measuring device, but now that USGS has this gauge, it's collecting data every 15 minutes and is automatically uploaded, and anybody from anywhere in the world can see the lake level on their computer or smartphone.
The biodiversity is something that astounds me. We were watching short videos at the California Coalition of Land Trusts meeting that ended last night, and a woman was talking about how amazing it is that they have this preserve with 47 species of birds. We've so far, the people in the Redbud Audubon have cataloged over 170 species of birds here. And it's just, the habitat is perfect for so many critters and it's just a very special place. And we're working, the Land Trust is working to return it to a more native habitat, and that's going to be a benefit to wildlife, but also to the lake itself. Because this property, the Wright Preserve, has the original delta for Manning Creek, which is the area of trees out there.
Clear Lake is very productive. There's a lot of food sources. So this means there's vibrant wildlife communities. There's lots of insects particularly that are born in the water and emerge onto the land, like dragonflies, damselflies, are very prolific and abundant here. And then that means that there's a lot of bird populations and bird activity because they feed on those insects. Clear Lake offers one of the top bird and bat watching experiences in the whole West Coast. So because Clear Lake and the surrounding area has ecoregions of oak woodlands, savanna, chaparral, wetland marshes, and grasslands, this means there's a wide range of flora. And it's really, a nature lover's dream come true. And it's a major resource for birds that are living in and traveling on the Pacific Flyway. And that's the major migration route that spans from South America to Alaska. Lake County, and particularly around Clear Lake, hosts hundreds of bird species annually. The area around Clear Lake is actually designated as an important bird area by the National Audubon Society. And that's because the landscape changes as the seasons do. There are birds here all year round, and so there is lots to see and lots to do for bird watchers. There's lots of amazing courtship habits, particularly from the western and Clark's grebes. There's acorn, woodpeckers. The tree that woodpeckers drill the acorns in is called a granary. And you can go to any of the parks and probably see an old tree that has a lot of these little holes with these acorns shoved into them. That is from the acorn woodpeckers. As soon as sunset comes on, you're gonna see these fast, blurry little blips in the sky, and those are bats. And the area around Clear Lake is very prolific with bats. They help keep our mosquito populations down. The area around Clear Lake in Lake County is home to peregrine falcons, which is one of the fastest birds in the world. And of course, Clear Lake is home to a population of American white pelicans. And these birds have the second largest average wingspan of any North American bird. And of course, we have breathtaking wood ducks, hooded Bullock's orioles. There's 3 species of grebes that nest here. And overall, there's about 300 different types of birds that make Clear Lake very important, not just for bird watchers, but for all the rest of the wildlife and anybody that enjoys nature. So the shoreline of Clear Lake is really important. Provides habitat, refuge for insects, baby fish, waterfowl, and of course, wildlife. So there's lots of native mammal species that call the shoreline around Clear Lake home. So there's muskrats, otters, Deer come down and utilize the lake and feed from the shoreline veg. And then of course, when you have these smaller mammals, you're going to have the mesocarnivores, so those are the next step up in carnivores. So things like coyotes and foxes are going to be around these shoreline and wetland areas. So it's really important that the shoreline along Clear Lake, in some areas left wild and not developed, to provide these habitat and refuges and places for wildlife. And it's also important that we maintain and control invasive species so we don't lose the natural vibrance and features of the shorelines.
Since the first peoples showed up here on Clear Lake, hitch were a very important food source because they came to the people. When those fish came upstream to spawn, I mean, you literally walked, ankle deep in water and picked up your food and dried it for the next 6 months. Incredibly important, as well as other native fish like tule perch were very important. But remember, prior to the 20th century, bass, crappie, bluegill were not in this lake. People were reliant on pike minnow, reliant on hitch, reliant on Clear Lake split-tail, reliant on thick-tailed chub. The latter of those two, the split-tail and the chub, extirpated from Clear Lake. The thick-tailed chub, which was once the most widely sold fish in San Francisco fish markets, has been removed from all of California. It is literally extinct. So it went from the most popular market fish at the turn of the century to gone by the mid-1930s. Most likely the result of overfishing, the changing in habitats from various impoundments and things, and the introduction of very aggressive predatory fish. All of the sport fish that people target, largemouth bass, smallmouth bass, black crappie, white crappie, bluegill, those are all introduced fish. They're all from east of the Mississippi River. None of those fish are native to California. They've been widely planted and transported throughout California. And originally, the bass that were brought to Clear Lake in the 1880s were from the northern climes of North America, Michigan and places like that. They were northern strain largemouth bass. In the 1970s, Florida strain largemouth bass were introduced into Clear Lake, and now they are the predominant genetic strain in the lake. They tend to grow larger. They tend to be more aggressive. The downside is, in the wintertime, they're from Florida. They don't like it cold. When the water's 45 degrees, 48 degrees, they shut down. But when it warms up, game on. I mean, those are very, very aggressive predators, and that's what people are targeting, are Florida strain largemouth bass, in the majority of those in those fishing competitions.
So this project right here is actually Hippomitl of Upper Lakes project, and it's their pit tagging project. And so thankfully enough, we're able to help them with that project. The plan is pit tag a lot of fishes and see which ones are migrating up the streams. So right now they only have one pit tag antenna up in Clover Creek, but the hope is to put this next year, I think 3 more. And then as the years go, we'll put more pit tag antennas in the other creeks. Some of the other projects like the carp and goldfish management, that's specifically because carp and goldfish are really good at eating eggs, and all fish eggs. So they devour them and the carp get really big. So for example, we tagged one carp 2 years ago. It was a female and it was 46 pounds. And so one study suggests that a 10-pound female can produce as many as, I think, 2 million eggs, 1 million or 2 million eggs. So if you kind of scale that up to a 46-pound female, I don't know how many eggs that one female would produce. And Clear Lake is huge, so there might be thousands those size. Remove the predation of the eggs in the lake if the hitch only have the lake to spawn, especially during drought years, because we do know that they are able to spawn in the lake. So when the creeks are not available, they can spawn in the lake. But if we get rid of as many carp and goldfish as possible, then hopefully those eggs survive a little bit longer. So the general life cycle, the adults migrate upstream and they find a riffle that has really good oxygen for their eggs, and they'll deposit their eggs. They're broadcast spawners. So the females will lay their eggs, and 1 to 3 males will try to fertilize those eggs. It just depends on the creek, depends on the year, whatever it may be. And so then those eggs sink and they like to incubate. And as long as there's water, they'll incubate for up to 2 months. But it has been shown that they could incubate for 2 weeks, and then the larvae emerge and they start making their way downstream. And so the goal of the juveniles, the larvae that emerge and the juveniles, is to kind of grow as big as possible in the creeks. So when they make it to the lake, they're able to evade predation a lot more. And so once they make it to the lake, they kind of stay inshore. And so they're right around 3 to 4 inches, maybe a little bit bigger. It just depends on the water year, a bunch of environmental factors. And so once they become big enough, they go out into open water, and they're able to survive out in open water and avoid predation a lot better. If the pond had good water for years and it was disconnected from the lake, they could definitely survive out there for years. Become as big as they can for that habitat, and then the floods could come and reintroduce them to the lake, and they could get a little bit bigger. But as long as the water quality is good for them, they'll be able to survive. So the temperatures are definitely important, but what we found is so it's kind of a thing between temperature and dissolved oxygen. But we do know that as temperatures rise in the water, the dissolved oxygen goes down. So with low dissolved oxygen, we don't really see hitch. But there has been some cases where we didn't expect to see hitch because of the dissolved oxygen levels, but they were there. So it's kind of a combination of things. But the pools that oversummered and overwintered, the temperatures didn't really get above 73 degrees, I believe. I'd have to get back to you on the exact temperature. But temperature was good, dissolved oxygen was good, and they were fine. And now I'm hoping they're just making their way slowly back down to the lake. We do want to protect these fish so they last, but we want to protect them to the extent to where there's a sustainable harvest rate. And so, I've talked to many elders from different tribal communities around the lake that say the last couple of generations haven't been able to fish for their native fishes because there's not enough. There's not enough to go around. We want all the tribal peoples to be able to harvest those fishes because, they are food. They are food, and they have been eaten for time immemorial, except for the last 30 or 40 years. It hasn't really been the case just because the populations aren't there. The Clear Lake splitstail used to be harvested for the same exact reason, and they're gone, they're extinct. And so we don't want the hitch to go next. For example, one of the tribal elders from Robinson told me that when the bittern, I'm not sure if I'm saying that right, but it's a waterfowl. When the bittern starts to call, that means the hitch are starting to run up the streams. So that's one thing that I have incorporated into kind of our observations. Kind of see what the rest of the natural world's doing. If you see a lot more waterfowl, or if you see kind of flowers blooming in the trees or along the landscape, make note of that, because, nature is talking to you. You just got to know how to understand it.
I previously worked for Robinson Rancheria for 25 years and started the environmental department there. Then worked for Scotts Valley, then worked for the state as a tribal liaison. And a lot of the Indian people here, of course, that was one of their main staples. And they did a lot of fishing, and they kind of, we kind of took for granted that they're all going to be here. And then slowly, like in 2000, we started noticing this so slowly disappearing, and it became kind of an awareness to us. Like, we need to find out what's going on. So that was kind of like the beginning of the tribe's awareness about the hitch decline. So we got a small grant to kind of look at it, and sort of start looking at what's happening with the hitch, and so that was kind of the beginning of it. And we started applying for grants, and then we started doing planning grants and doing some implementation grants, and just, took it from there. Robinson was the first tribe to do that. And then I says, well, we can't do this alone. We have to invite the other tribes to start applying, for the same monies. And so eventually we all worked together in partnership to encourage all the other tribes to be involved and come together. We get more money if we were collaborating and partnering. So that's what happened over the next course of 5 years, and we just started doing all this amazing work in monitoring, sampling, just everything that involved in trying to save the hitch, and even restoration projects. So there was a lot involved, and we just kept with it from then till now. And we're still working on the projects. We're still doing all those things that I mentioned, and so it's grown into a bigger deal now, involving the state and the federal and county. They're getting more involved, and so I just think it's grown to where it is today because of the tribes moving it forward and seeing it as an important, sustainable food for us. So just want to keep that alive and keep, making sure the fish are healthy, and fish can't be healthy without the water being healthy and our environment being healthy. So it all pieced together, that we can't just do one piece, we have to do it all.
And so when we started this project, there was a need to try to figure out how we could collect as much information as we possibly could with limited resources, right? We all have very limited budgets, and so we came to the decision of doing this gillnet survey because it allowed us to collect information on a pretty large range of life sizes, age groups of Clear Lake hitch in one survey. And so this is a kind of a general conceptual diagram of the life cycle of the Clear Lake hitch. And so we've got fish that are in the lake and fish that are spawning in the streams. And our gillnet survey is capturing fish in the lake that are basically age 1 and above. So I mentioned earlier that we have 5 different mesh sizes in these gillnets. You guys are welcome to walk over and touch them and feel them and even pull the nets in. So we're able to capture age 1 all the way up to as big as the fish get with these gill nets. And so we're capturing a lot of the life cycle and getting a lot of information on these fish in just a single survey. It does leave a little bit of a black hole for these very early life stages in terms of the really little babies. And there's some work that's being done by CDF&W and some others that might be able to kind of help solve that particular data gap there. But we do this survey now in early summer for a few reasons. One is that the entire population of Clear Lake hitch is essentially constrained to being within the lake right now. So if we did it earlier in the year, there's a potential for fish to be up in the streams. And so we would then not be, sampling the full entire population. And the reason why we don't do surveys up in the streams is that because it's very hard to collect consistent data year after year on the counts of fish in the streams. So any given year, fish may be in one stream versus another. They may be in a particular stream at a particular time. Based upon water quality conditions, based upon flow conditions. Flows might be really high one year and you might not be able to see the fish, so it's practically impossible to get a really good, consistent count of fish in the stream. So that's why we do it in the lake, so that we actually have the full population here vulnerable to our sampling gear, and we can actually count and measure them. And we do it right now before it gets too hot, so that it's still a little bit relatively cool compared to the rest of the summer, to minimize stress on the fish as well. So that's that piece of it. So I mentioned earlier that we kind of allocate our effort kind of proportional to the surface area of the particular arms of the lake. And what you saw here basically constitutes a deployment of gill nets for a particular site. Site deployment roughly maybe about 100 times for each given survey that we do a year. So on average, we get about 200-ish samples of gill nets. And so we collect a lot of data. And this is a map showing you all the sites that we've sampled and deployed gill nets at over the course of the study since 2017. So we sampled the entire lake, and are attempting to get a really good estimate of the numbers of fish throughout the whole entire lake here. Over the course of doing this work, we've learned a few things. I mentioned earlier also that the first thing we do when we get to a site is we do a water quality profile to check out what the water quality conditions are like. And we do that because we learned early on that these fish, the Clear Lake hitch, don't like to live in dissolved oxygen concentrations less than 2.0 milligrams per liter. And that's what this plot is showing you here. So this is data showing you the count of fish in our samples for both adults and juveniles in hypoxic samples less than 2.0 milligrams per liter, and then what we call normoxic or normal oxygen conditions. You can see that the frequency and the numbers of fish in the samples are much greater in the normoxic conditions than the hypoxic conditions. Another thing we've learned is that there is some habitat segregation that goes on with the various life stages. And so this is just kind of a general representation of what the data are showing you here. And so we sample and we deploy nets at locations throughout the entire lake, and we can kind of, we can look at those data and learn a lot of things about where these fish are living in terms of the habitat conditions they like. And one thing that really stands out in addition to the dissolved oxygen concentration situation is kind of near shore versus offshore. And what this plot is showing you here is the count of fish in our samples for both the juvenile fish and adult fish, close to shore versus offshore out in the middle of the lake. And what this is showing you is that juvenile fish, there's a lot of juvenile fish near shore, as we all kind of thought and believed. We also collect a fair number of juvenile fish out in the center of the lake as well. The adults, on the other hand, relatively few of them near shore, and the majority of them are out in the open water. So on any given day, any given sample, you can observe a fish literally anywhere, but this is kind of the overall pattern and trend that we see in our data. And so here's kind of the overall punchline in terms of the status of the population. And so this is data through 2023. So we don't have 2024 data on here yet because we're literally collecting 2024 data right now. So on your left here is a plot of the abundance indices for adult and juvenile hitch. And again, this is a mean catch per unit effort with 95% confidence intervals around them. And then on this side here, this is the length frequency distribution of the fish in our samples. And so what this is showing you is the count of fish each year by size. So this is 150 to 350 millimeter size fish. And there's been a really interesting pattern that we've seen over the years where 2017, when we started our survey, we saw pretty decent numbers of fish, especially juvenile fish. And then starting immediately in 2018, you can see that these juvenile fish really largely disappeared. And these fish kind of grew into this age group, right? And you can see that kind of continue, but those numbers get lower and lower. That's because there's been no recruitment of juvenile fish over the last several years. So from approximately 2018 all the way to 2022, we saw very little, next to zero, recruitment of juvenile fish into the population. And you can see how that kind of manifested into the older age groups, where those older age groups just, the abundance of those fish got smaller and smaller and smaller as well. And so we got to the point where, to give you a sense of the level of change in the population, in, I think it was 2018, in a single net set, we collected as many as 77 adult hitch in one sample, one of these net samples. By the time we got to 2022, we caught 6 fish for the entire survey. That's how far the numbers had gone down. And so when we got to 21, 22, there was a lot of concern with everybody in terms of, thinking this population was really at risk of potentially kind of fading out. And so there was a lot of interest and a lot of work that's been put forth trying to figure out what exactly is going on there. To give you some context too, with kind of the scale at which this recruitment failure, the importance of it. So this is a fish that lives 5, 6, 7 years of age, and we're talking 1, 2, 3, 4, and then goes up a year, 5 years of recruitment failure. So if you put that in the context of a human population, you know, we're talking about no babies being born into a human population for probably 50, 60 years. And so, you know, that wouldn't be a good thing, right? Obviously, that would be pretty detrimental to the population. And so this, you know, we were really concerned that this was going to be very detrimental to the population as well. And then 2023 happened, and we're still scratching our heads about what happened in 2023, because fish essentially magically appeared out of nowhere in the lake. We went from several years of no fish to all of a sudden being almost record numbers of fish in 2023. And this is something we're still trying to wrap our heads around. We've got a few hypotheses that we're trying to look at and trying to answer this question about what happened.
Our goal at Robinson Rancheria is to help Clear Lake become Clear Lake again. It's lost its identity for a lot of reasons, as we know, but those could be remedied in our heart, and those are our responsibilities of being the ancestral inheritors of this land. And so with that responsibility come, how are we going to do it? What opportunities do we have in bridging those opportunities? When you can start helping your homeland and the land itself, whether it be taking care of it, acquiring it, getting grants to clean it, as well as the cooperative grants that we have with other tribes in the county, that's where work and government and tribe and responsibility come together. And it's just an honor to be a part of it, to see these grants in action of removing invasive fish in our lakes to help our indigenous spawning of our chai, of our birds, of our feathers, and then the other fish that are from here. So it's just been an honor to see this growth, to be on the be right there where you can see it happening. You can see the tribes working together. You can see the county coming together with meetings. Just a great opportunity to be a part of.
All right, yeah, Terra, it's a nonprofit organization. We work with many tribes around the lake. We think we actually have about a couple tribal members from each tribe of the lake. That'd be from Big Valley, Robinson, of course, Scotts Valley. Got a guy from I think Point Arena, Kashaya, and then another guy from Laytonville. So we collaborate with all the tribes that we can. This project right here is a BLM project, trying to reduce the ladder fuels. As you can see, it's pretty bad. So yeah, we're just thinning and limbing, trying to save the oak as we can. A lot of medicine here. Like you said, you can feel the good vibes of medicine here. And so with that, we're just trying to restore this land to to give it back to Big Valley. This is their ancestral lands, and so we're just trying to give them a hand and help them out with this. I have a great, I guess it goes back 4 traditions back, so it'd be a great grandmother that survived the 1850 Bloody Island Massacre. Just thankful for her surviving, her doing her sacrifice, for letting me be here to this day. So with her doing that, so it's paying back the respects that I have for the land by her doing the sacrifice with the tule. So yeah, but like I said, tule's pretty much medicine, or it is medicine, life of the lake. We use it for many different things with the cultural aspect. Being that you use it for skirt making for the dancers, put it on the huts for our homes. We even have a tule boat festival coming up next weekend, and so we use a lot of tule for that. You could even eat the tule. It's edible. It's also a filter of the lake. Like in 1890, this lake was covered in tule. 90% of it was tule, and now to this day, there's only like a 10% of it left in the lake, due to the urban development. And so with that, just trying to get the landowners and the people around the lake that live here, just restore the lake as it was natural to what it used to be. And so like my dream one day is to have my kids, I know I probably won't see it, but my kids' kids, be able to drink out of the lake like we were able to do that 150 years ago.
Robinson Rancheria was reestablished in the late 70s. Then we came home in the mid 80s to become established as a rancheria again. But since that time, it's been over 30, almost 30 full years where we've been an economic force on Highway 20, where we've created jobs and opportunities and things that cost at a lower amount and entertainment. And we look to expand that in the future. But being an economic force on Highway 20 is just one of our tribes. All the other tribes have that opportunity to help this community too. So when you think about what reestablishment meant, getting land back meant it helped everyone. It didn't just help the tribe. Having over 250 employees at our facilities on Highway 20 isn't all tribal members. It's all community members. And so trusting our process, trusting our land, our instincts of, that's the economic side. Okay, now let's focus on what we can do for the land, to help with fire, to help with water protection, what we can do with our intrinsic knowledge from our ancestors. Give us that opportunity to help and trust us that this land wasn't abandoned, it wasn't overgrown for hundreds and thousands of years, that we took care of it, and that responsibility is still ours. It's just that that responsibility has been kept from us. So as we team together, watch what we can do, watch the intrinsic ecological opportunities and knowledge that we have for our own land right here in Lake County. So trust that process. We've already shown you economically what we can do. Now let us see allow us to show you what we can do with the land and the water and the hills and protecting this. So I just think there's more opportunity for us because there was a long time where is our value? What can we do? Where do we belong? And now we found our footing, and just let us continue to thrive and grow here and watch these things get reversed and back into balance. That's our opportunity. That's our youth's opportunity.
In 2000, Bassmaster magazine, which is the leading periodical addressing bass fishing in the United States, well, in North America, including Mexico, named Clear Lake the best bass fishing lake of the decade. It's always ranked in the top 3 in the nation. I'm not talking California, I'm talking in North America, the best bass fishing lake. The reason is because of the consistency of fish, the size, the number of fish that you can catch, and the availability of record-size bass to be caught. There are, on an average of 100 competitive fishing tournaments a year on Clear Lake. They're not all big. Many of them are club tournaments that might have 15 or 20 boats. Sure, the big boys show up and we have 120, 150 boats. But again, it's because of Clear Lake's productivity. Bass were introduced, and most of these tournaments are for largemouth bass. There's a handful of catfish tournaments, 3 or 4 a year, that are very popular and bring people in from all over the state and western United States. And in past years, we've had archery tournaments targeting carp. And those have come and gone, and depending on who the sponsor is, but those tend to be very popular as well.
Because Clear Lake is so different, we don't have a surefire silver bullet method of addressing issues that we see in the lake, such as over-nutrient, so she's hyper-eutrophic, which means there's too many good stuff that's produced in the lake. And it's a good thing for fisheries. So we have a world-class fishery, and that's because we have so much food that's being grown in Clear Lake. She's shallow, she's got a lot of nutrients. There's so much of that food web that's being built that there's so much for fish to eat, and that's why people come from all over to go fishing in Clear Lake. And those same things that make that lake so prolific for fisheries are the same things that add to those large harmful algal blooms that we see in the summer and fall that can create noxious smells, can cause health hazards.
It's not a surprise that nutrients are an issue, that oxygen levels are an issue, that mercury is an issue.
But we had to nail down where the sources were, what the greatest sources of those were, where they're settling, like the mercury, where it's most concentrated, where the phosphorus and nitrogen are most concentrated. And we've been able to do that. And then the question is, given where they are and the amounts, what are the best ways to reduce those amounts? Clearly, the best thing you can do with the phosphorus and other nutrients coming off of agriculture is stop it from coming in the first place. But it turns out there's a lot of natural nutrients in the lake as well that are just that come up from the soil over this enormous expanse of shallow water. So you have to identify the hot spots and also tracking where those hot spots of the nutrients affect where the hot spots of the algal blooms are, because wind and sunshine and climate can affect it as well. So it's really mapping the lake on a three-dimensional basis to identify where the problems are most acute, both in terms of inflow and presence of these elements, and then what are the best ways to reduce those within the lake and going into the lake. So, around the lake, it's going to be recladding roads, getting culverts put in that are proper, making sure that water, when it comes down, doesn't run into the lake, just bringing all those nutrients with it, that it puddles and then settles so the nutrients stay on the land rather than in the water. At the edge of the lake, more tule, more wetland can help be a filter to keep these elements from entering the lake. So that's on the entering the lake part of it. Inside the lake, we're going to be doing a bunch of experiments with techniques to try to remove these elements. There's an oxygenation process which can help reduce the ability of these algae to grow and attach with their nutrients.
A problem that we have with the lake is that it has a lot of cyanobacteria because in the summer it gets really warm. There's a loss of oxygen in the bottom, and that allows for a lot of phosphorus to come up out of the lake bottom and recycle. More than usual for any lake that you'll find. A lot of recycled nutrients. And the one that's not limited at all in this lake would be phosphorus. So that is really the problem that fuels cyanobacteria. When you get a lot of cyanobacteria, of course, you're going to have green legs when you're water skiing. And this turns a lot of people off. And the other thing is sometimes it brings toxins with it, which can cause a problem for if you were to get it in your eyes. For certain, if you had a dog to lick it, a dog can come up with a liver problem. And we've had some dogs that have died here as a result. So with all that said, what you really want to have is a way to control the phosphorus in the lake. There's been a lot of research in this lake. It started back in the 60s, and probably the best thing that ever was done was by an engineer by the Water Resources Department who says, there's so much sediment coming into this lake from the landform above it, the water basin, that's what's really creating these cyanobacteria. And the lake could actually fill in 5,000 years because there's so much coming in. Now that was in the early 60s. And that recycling sediment has been happening here ever since. What we don't know is what the lockup and loss rate of the nutrients are. So it can go out over the dam and out down Cache Creek. There's a small dam on this lake, even though it's natural. Or what is the lockup from other heavy metals that might lock up with the phosphorus so that it doesn't recycle? We don't know that. We don't know how much is coming in, and we don't know what the absolute level in the lake is. If we had those ideas in our head, we could start to develop a management plan so that the phosphorus would decrease to a level where the cyanobacteria wouldn't be on steroids. Where did the phosphorus mainly come from? Well, it comes from the sediment. This is a high phosphorus sediment level area, about 0.8% of phosphorus in the soils in some areas, a little bit more in some others. National average for phosphorus in the soil is probably 1% or 0.1%. So there's a little more phosphorus here because it's a volcanic landscape. And so where you get sediment coming in that has that high phosphorus, that's going to make a difference. There is some good research into fingerprinting these sediments that come down to different streams to see where they come from and how much phosphorus is there, and that's going to help us quite a bit. But it's mostly coming in through the Middle Creek area. There's some that's coming in from the Big Valley Creeks and Kelsey Creek over in there. Certainly not in a high percentage that comes through the Middle Creek. So Middle Creek has Clover Creek on it, Middle Creek, and it has Scotts Creek. And all three of those converge right at the Middle Creek or Rumsey Slough area and comes into the lake. There's even a island that's formed outside the exit of that stream into the lake. And you can see it over the years, in the last 10 years, that island has formed, just showing you how much sediment comes in. That's a hot spot. And if we could either control that, dredge it, use lanthanum or something like that in order to lock up the phosphorus, I think that's going to help.
It's phosphorus and iron. Where does phosphorus and iron come from? The surrounding soils. These volcanic soils are loaded with both phosphorus and iron, and it's transported in sediment. What's the greatest source of sediment in California in any forested situation? It's roads. Road-related erosional sediment is the #1 transport mechanism to move dirt off the hills into a water body, whether it's a stream, whether it's a creek, whether it's a river, or whether it's a lake. So identifying the source of that erosional sediment and what drives it has gotten places like Clear Lake and the Forest Service to start moving towards eliminating or at least reducing as much road-related sediment as possible. That's how you move things in a positive direction. Clear Lake is not out of balance. Clear Lake is responding to the conditions that are there now.
One of the projects that I know is in my district that we deal with is the Middle Creek Restoration Project, which we're still in the process of buying all the properties in that area. The goal is to actually flood that area and make it get into a marshland again. And that will provide some area for the sediment and all of the other pass-throughs to go into that area and help with ensuring that the lake has less nutrient load. It does another avenue is it helps a nice habitat for the hitch.
It's a beautiful lake. It's a unique lake. It's, compared to, say, Lake Tahoe, which is very deep and very clear, this is almost the opposite end of lakes. It's very shallow, it's very complex, has 3 arms, and it's not clear despite its name. So what we learned in those early years was how dynamic this lake is. And literally in an afternoon, it can change. The currents are extremely high compared to any lake, and it can move mercury or mercury compounds from one end to the other in a matter of hours. And those physical principles of how the lake moves are equally applicable to some of the contemporary problems like harmful algal blooms. And so that's what we've been sort of studying here. We were asked when we started this most recent project about 6 years ago, to help understand what could be done to rehabilitate Clear Lake. And I think what we've been able to do in this relatively short period is now fully understand, to the extent possible, the physics of the lake, how that drives much of the biology and the very complex biogeochemistry. We've built a model, a computer model, that is reliant on these physical processes to enable stakeholders, the public, all the various entities here to use that model in a predictive manner to answer questions like, if we reduce, say, nutrients coming from the watershed, how will that change the lake? What will happen as climate change takes a greater hold on our planet? Will that help us, or will that hinder investments and things we've done?
So our current project in Clear Lake is mostly focused on understanding why the poor water quality in Clear Lake. And to do that, we have 2 main components in our program. So the first one is what we call monitoring, which essentially means measuring different things in the lake. And the different things in the lake that we can measure are very broad, right? So we mostly focus on physical properties such as temperature, oxygen, turbidity, but also biological and chemical components, right? Like nutrients or any kind of changes in the phytoplankton. But the one thing that I want to stress about what we are doing different compared to other programs is the high frequency or how fast we sample with some of our instruments. So essentially, back in the days, we were used to like go to the lake, take a profile one day, and see how the lake was at that specific day. But what we are doing different now is to have instruments in the lake, as they are right now, measuring continuously temperature and oxygen at different locations and depths in the lake. And what this is showing us is how rapidly the lake is changing. And as Jeff was mentioning before, that's one of the unique themes of Clear Lake, right? So essentially, this lake is really dynamic and it changes very quickly from one day to another, and what it's more like every hour. So things can be very different from the morning to the afternoon.
So to build on what Alicia was saying, Clear Lake, as we all know, is a very organic, rich lake. It has lots of algae. It's why it's such a great fishing lake. Because of that, when those algae die, they fall to the bottom, and then they start to decompose. When they decompose, they lose oxygen. So one day, Clear Lake can be sort of very well oxygenated, lots of life, top to bottom. The wind stopped for a few days or a week. The bottom of the lake loses its oxygen literally in days. At that point, all hell breaks loose, meaning in the absence of oxygen, mercury comes out of the lake sediments, phosphorus comes out of the lake sediments. So within a matter of hours, the oxygen at the bottom of the lake is consumed by this decomposition. When that happens, you start getting releases of phosphorus. And it turns out the work we've been doing is that something like 80% of the phosphorus in Clear Lake comes from the sediments during these periods of low oxygen. We call them anoxia. It's also important for the mercury because that's the time under anoxic conditions when methylmercury forms, which is the form that gets into the food web. So what can you do about it? Well, ideally, we could just have more wind here to keep the lake mixed up. Can't do it. But there are engineering solutions that are being applied worldwide and in this country extensively, particularly in the southeast, where you replace that oxygen, you add it to the bottom of the lake. And that's one of the things we thought about. We tested it with this model, this computer model that we built, and we saw, yes, it does work. We could inject pure oxygen into the bottom of the lake with very fine bubbles that will dissolve close to the bottom, and we can compensate for this loss of oxygen. If that happens, then we will cut off this release of phosphorus from the sediments, we'll cut off this release of mercury from the sediments. And in a way, we will stop the negative effects of these processes here at the lake. It's a huge lake. Every lake is different. So what we've proposed is let's try this in the smallest arm of the lake, the Oaks Arm. And so we've been granted funds to run a pilot project to oxygenate the entire Oaks Arm. And as I said, this is a technique that's been used in many places, but in some ways, because of its dynamic nature, what we've learned about the lake, we're going to learn things through this pilot project. And the idea is we'll learn things. Yeah, so we've proposed to the Blue Ribbon Committee that we conduct a pilot project of adding oxygen to the lake. This goes by a technical term, hyperlimnetic oxygenation, or HO. So the idea is it will definitely work because it's been done in many places, in that very fine bubbles will come out of a long diffuser, say a mile-long diffuser in the bottom of the Oaks Arm, and those fine bubbles will dissolve, and the currents within the lake will carry it throughout the Oaks Arm and possibly into some of the other arms. What we're going to learn is how much oxygen should we be adding, should we add more? Should we add less? When should we do it? All those things that would guide a potential future full-scale HO operation for the lake. And we'll also evaluate the economics of it. again, that's not our decision. We do this work on behalf of the Blue Ribbon Committee, and we report our scientific findings to them.
So I can add that in addition to that infrastructure that Jeff has defined for the HOS system, we are going to do post-monitoring, essentially post-sampling of how this system is working and affecting the lake after the addition of oxygen.
One of the anticipated outcomes of this, because we're cutting off the release of phosphorus, is that there'll be fewer algal blooms, fewer harmful algal blooms, and then the ongoing monitoring program that the Big Valley Rancheria runs in partnership with others for the beaches around the lake, that will provide the validation of, is this really working? How much have things changed?
Because the tribe is located on the shores of Clear Lake, the largest natural freshwater lake in California, and relies on this lake for sustenance, for ceremonial uses, and for all things having to do with life and health. We have a program that tries to address the issues that the lake is dealing with right now. Our program on Clear Lake has to do with surface water monitoring, mitigation measures like tule replanting. We're paying attention to what herbicides are being used on the lake. We're looking at water chemistry trends. We're looking at cyanobacteria issues, and it's a lot of fun. It's great work. The tribe is very involved in the activities that we do, having to do with monitoring and other activities. So the tribe is engaged in research to understand what water quality standards are needed to protect tribal traditional activities on the lake and also in the watershed. And that means that, first of all, we are trying to get the word out to agencies that tribal traditional activities do not look like regular recreation, regular fishing that is currently protected for water quality standards. So what's really important to our program here at Big Valley EPA is to be able to understand the exposure scenarios for the tribal activities and the different pollutants that are in the lake. That's incredibly important to us. There are projects that are happening that have to do with replenishing the tules. Big Valley has been doing tule replanting since 2011, possibly earlier, and that is because the tules are a source of food. They're used for ceremonies. They're used for habitat for the important fish and birds and other aquatic organisms of the tribe. So we support tule replanting, cultural burning that the tribe is now re-engaging in, and we want others to incorporate those into their programs. But ultimately, what we're working on is to understand what water quality standards will be important to protect tribal uses. So looking more deeply into particular water chemistry parameters, if you look at, let's say, pH, the pH is the measure of how acidic or how base the water is. There's already a standard for that for aquatic organisms and for humans. And the standard for Clear Lake for those uses of the lake is between 6.5 to 8.5. Now, our measurements have shown that, especially during the summer, that the pH is increasing due to cyanobacteria blooms, and we are seeing pH levels of over 10. Now, that is well outside of what's considered the safe level for the different uses of the lake. And with Big Valley traditional activities, if we have young children that are in there for ceremonies or in there for a number of hours, deliberately swallowing the water, how is that actually being factored into to protection of those uses when really what the state is looking at is a certain amount of time in the water, a little bit of water being swallowed, and that's what exposure looks like. So there are a lot of assumptions in exposures, in uses of the lake that don't really factor in tribal traditional activities. We want to make sure that that message is loud and clear with agencies and managers of the watershed that tribal uses look different and need to be protected fully. And we don't think that's going on right now because at the state level, those uses have not been fully integrated into the plans. They're also not integrated into cleanup levels for like the Superfund site. They're also not integrated into permits for pesticide applications and for stormwater runoff. These are all part of the Clean Water Act, and the Clean Water Act is something we understand very well at the tribe because that is the federal law that's being implemented by the state and also by the tribes to protect the uses. That's really important research to us. It's an important part of our program to be aware of it, to be working on those issues, and to understand what are those water quality standard ranges that, that would be protective of tribal uses.
The Sulphur Bank Mercury Mine opened in 1856 and closed about 100 years later in 1957. Throughout that time, they mined sulfur and borax, and then predominantly mercury. Over the course of that 100 years, they pulled almost 10 million pounds of mercury out of the ground here. 1856, the Sulphur Bank mine opened on land that had been stewarded by indigenous peoples for over 14,000 years. They began with extracting borax and then sulfur, and then predominantly they switched over to mercury in the 1870s. The mine closed in 1957 after just over 100 years of operation. In that time period, they extracted just shy of 10 million pounds of mercury from the ground here, and in so doing spread about 3 million tons of contaminated waste across the site. The waste rock that you see in piles behind us here contains high levels of arsenic, mercury, and antimony. Those are the primary contaminants in this material that cause risk for the public. Over the course of the operations, about 3 million tons of waste were distributed across the site. In the decades that followed the mining activities, contamination was introduced onto the Elamidian colony, which is immediately adjacent to the mine site, and into the residential neighborhood to the south of the mine. Both during operations and in the decades that followed, mine waste also has eroded directly into Clear Lake. And so the site poses a direct risk, direct exposure for the communities nearest to it. And the mercury in particular has accumulated in Clear Lake, so that there is a fish consumption advisory for the fish in Clear Lake. That's the primary way that the majority of the public would be exposed to contamination from the site. It's important to say also in that context, though, that Clear Lake is not unique in having a fish consumption advisory. About half of the freshwater water bodies in California have fish consumption advisories for mercury. It's part of the legacy of the state's mining history. So the Superfund program is sort of the nickname for the Comprehensive Environmental Response Compensation and Liability Act. And it was passed by Congress to help clean up the most contaminated sites in the country. And the Sulphur Bank Mercury Mine was added to the Superfund list in 1990, primarily because the impact that the mine was having on the Elamidian colony in particular, but also all of the users, sort of human and wildlife that use Clear Lake. So we've taken 8 emergency cleanup actions to date at this site to address the immediate risk for the residents, addressing the contamination in their communities, preventing ongoing releases of mercury from the site into Clear Lake, and the complete cleanup needs to be documented in something called a record of decision. And in November of this past year, EPA signed the record of decision for the cleanup of this site, so that we now have the decision authority and funding authority to clean up the mine and the residential neighborhoods north and south of the mine. The other 2 aspects of the site are Clear Lake itself, which is another what we call operable units. And we are continuing to evaluate that. We're fortunate to have the collaboration with the U.S. Geological Survey, who's also coordinating the work with the work the Blue Ribbon Committee is doing to clean up Clear Lake. And then there's a wetland area to the north of the mine adjacent to the Elam tribe's lands that is a component of the site as well that we're continuing to study. The selected cleanup approach that's described in the record of decision basically envisions consolidating the waste piles at the site, taking some of the smaller piles and combining them with some of the larger piles, and then covering them with a cap similar to what they use on landfills. So it'll have a couple underlayers, a thick layer of plastic, and then 2 feet of clean soil on top of that. We also really want to focus on moving clean water away from Herman Impoundment, the flooded mine pit. That mine pit is filled with water. It's being fed by a spring beneath it, and it's continuously fed by a natural spring. Before the mine was here, it had sort of a hydrothermal, bubbling, hot spring kind of environment, and that spring always would have naturally flowed to Clear Lake. And so what we're doing is we're cutting off the sources of contamination that flow into the impoundment, so that in the long term it will be just that natural spring that will be continuing to fill Herman Impoundment and then flow into Clear Lake. We're removing the contamination. The Waste Rock Dam is this waste pile that's between Herman Impoundment and the lake, and we want to remove the material from the Waste Rock Dam that groundwater flows through, so that we have spring water flowing into Herman Impoundment and flowing into Clear Lake without interacting with the contaminated mine waste. We want to make sure that we really have robust protections in place for the rich archaeological and tribal cultural resources that are present in this area. If everything goes according to plan, we are hopeful that we can begin work as soon as summer of 2025. After that, we expect to be basically doing one phase of work each year, and we have 4 total phases of work to complete. So starting in 2025, we will end in 2029 or 2030. And so at the site, there will be a long-term operations and maintenance plan that will be established. EPA will implement that plan on tribal land, like on the Elam Indian Colony, and for the first year after the cleanup is completed. It'll then shift over to the state of California to operate. It'll include things like preventing gray pine from growing on top of the caps. And so long as that plan is followed, this remedy is meant to protect the community for 500 years, protect Clear Lake for 500 years. That's part of why EPA is doing more upfront. We are removing more material, removing more of the Waste Rock Dam away from Clear Lake to ensure that even under climate change scenarios where Clear Lake's water level may go up and down more frequently, we're making sure that there's not flushing of Clear Lake water through waste material. We want to pull all that material back and ensure that the protection that we implement here is permanent.
We're here today doing an invasive creeping water primrose removal project. We're here at Library Park in the city of Lakeport, one of our partners on this project. And I'm here with the Tribal Eco Restoration Alliance, and they're a major partner in this project also. So what we're doing today is removing primrose, and you can kind of see it here. And there's not much back here. What you're actually seeing is the native smartweed. And that's because we were at the site about 2 weeks ago and did a large removal of primrose. So today all we're doing is spot removal. So some of the primrose we missed or that has grown since then, we've removed. And you can see it's not that much. But if we were to leave this unchecked and just let it grow, in about a few weeks, we'd see 2 feet of really thick primrose growth in here, and it might start to choke out this native smartweed, and may even start to choke out the native tules, which are an essential plant for the riparian aquatic zone along the lake shoreline. And so we're just really grateful for partners who are able to help us today, and doing these spot treatments by hand is really important, as well as long-term maintenance of your shoreline. When it comes to things like invasive species like primrose, it's maintenance periodically and consistently to be able to make sure it doesn't grow back into the amounts that can be troublesome, nuisance, and actually detrimental to our shoreline. One of the main things about primrose, if it gets too thick, it makes the water kind of stagnant, and that is prime breeding ground for the mosquitoes that carry West Nile virus. So not only is it an ecological concern, but there's also a public health concern with letting this plant get too big and cover too much area. And today we're going to learn how you can manually remove patches of creeping water primrose from your own shoreline. So this might be a typical shoreline behind your property. You have some native tule. You might have some other sedges or carex species. And then, of course, you might have some creeping water primrose. The way that the primrose grows is it roots in the shallow water, sometimes on the shoreline in the dry spot, and then it creeps over the surface of the water. So this primrose just grew within the last couple weeks, and its roots are still in the bottom sediment or soils, which is kind of loose. So this is a relatively easy time to remove the primrose. So what you want to do when you're working around water, of course, is be safe. Make sure someone knows where you are. Make sure if you need, you have some protective personal equipment. There's other things in the water. There's things like swimmer's itch. There could be lures, fishing lures, hooks. There's also little bugs that like to bite and nip. So you just want to wear some gloves, be protective, just when you're working in your shoreline and in the water in general. And what you want to do is you're going to gently grab the primrose from the stem as close to the bottom or base of the plant as possible and gently pull up. It's kind of like strawberries. It goes and sends out runners. And what you want to do is pull up the roots. If you just pulled it and yanked and cut the stem, then a new plant will grow back and it'll be stronger and more vigorous. So we really want to pull from the root. So you can see here, I'm just kind of gently pulling. And you might not always get the roots. I have some roots right here, some root chunks, but I didn't get all of it in the whole time. So once you pull up the primrose, this is kind of what it looks like. You have the part of the green growth that grows on the surface, and then you have these long root sections that'll bury themselves in the sediment. And this is really what you want to gently pull up when you're trying to remove this plant. And once you remove a chunk like this, you want to make sure that you don't just throw it back in the lake, because it'll go float somewhere and regrow, and then it'll become another problem. So what you want to do is you can put it on shore or your dock, making sure that it doesn't get back into the lake, and let it dry out, and that'll make it really light. Or you can put it directly into your compost bin or your green waste bin. And it takes a while to do an area, but once you do that, you're going to see less and less primrose growing in that spot over time. And it's going to be a lot easier for you to manage. And it'll help promote a healthy natural shoreline, which will benefit Clear Lake for improved water quality and provide habitat for fish and wildlife.
My job takes me all around the lake, and I've seen through several years what the primrose is doing on the lake. The effects it's having, how widespread it's become, and that's caused me to be pretty concerned about what we have here. This is kind of a nightmare plant, and it's very aggressive. It's spreading by seed, as far as I can tell, and it's getting everywhere, and that seems to be an exponential sort of deal, where it used to be here and there, thick in some spots, not even appearing in others, but now, with my job getting all around the lake, I'm really seeing it everywhere. You know, a lot of people have a lot to lose if the shoreline goes away on Clear Lake. And I think that's the threat that we're looking at. In certain places, access is already diminished to the point where you can't run a boat out. And if that happens on a big, grand scale, it's going to be devastating. So that's my concern. And meanwhile, every day we lose ground to this plant. Most people haven't even heard of it, don't really know the threat or even what it looks like. I tell people everywhere I go, don't let this get established here.
One of the things we're doing with this project is removing the primrose, managing the primrose, and then we're going to follow through with some native plantings. For example, this is a natural native plant shoreline area. We have a native smartweed here. You can see there's a bee pollinating it. This little pink stalk. You can see the smartweed, it grows very tall, straight. It doesn't creep like the primrose, so it's really more beneficial for wildlife. When there's water here, the fish can swim through it, the ducks, the waterfowl, they can all use the species in a way they can't with the primrose. You can also see that we have the tule here, or the bulrush, growing with the smartweed. And this is really important for lake ecology and as well as a cultural beneficial use. And so the goal is for us to restore shorelines from just all 100% creeping water primrose to mixed native species communities like with the smart.
My name is Dino Cloud. I work over at Terra, crew member at Terra. I am pulling primrose. Primrose is a very invasive species. It's very bad for our lakes. It chokes out all of our native plants, especially our tules and our smartweed. We need our tules to help filter our lake, and we need them for certain fish. Also, we also use tules for our cultural benefits as well. And it's not hard to pull it. Just take a couple of minutes outside every day in the cool, pull some smartweed, some primrose, and that helps get rid of it.
So here's one of the primroses. They have really long roots that grow. They grow out, and then cover all the native plants. And basically, it's so invasive that it blocks them out, basically killing them, suffocating them, and it just plans to take over everything. So that's why we're out here picking all of them up from the root out to kill them, so that way we can push it back all the primroses we can possibly.
So I'm gonna show you something. This plant is just as happy free floating in the water with these types of roots as it is, which is adds to the challenge. It's an aquatic plant. It loves the water, and it's really well adapted to just take off and spread like crazy.
And we're working under a grant right now from the Department of Pesticide Regulation from the state of California. So we're really excited for this project. We got a great crew. This project will be going till 2025. We'll be working at sites like here, Lucerne Park, the Wright Wetland Preserve by the Lake County Land Trust, Anderson Marsh, Cache Creek area, Clark's Island, and the state park.
People ask me where I'm from. When I tell them I'm from Clear Lake, if they're biologists, they always do the same thing. They drop their jaw and they say, Clear Lake, the world's favorite eutrophic polymictic lacustrine ecosystem. And they know it. The whole world of biologists know it. And you can translate that. It means the world's favorite shallow green lake. For me, what's special about this lake as a biologist is its productivity. So in old numbers, from years ago, we did about 7,500 kilocalories of energy converted from sunlight into something that other organisms can use in every square meter of this lake. And there's 65 square miles. That's a lot of production of oxygen and organic matter. So in round terms, you have an ecosystem, a lake, that is perhaps 2 million years old, and it's inhabited, its most important occupants, as far as I'm concerned, are 2 billion years old. These are the forms that invented photosynthesis and created our present atmosphere. They are marvelous organisms. They can fix nitrogen, they can adjust their own depth in the lake, and hardly anything eats them, which is another nice thing about Clear Lake and interesting to me. So that one of the principal plant forms doesn't get eaten directly. What happens to it? It dies, it falls to the bottom, it gets rotted, and then it supports a very healthy benthic ecosystem. This is how wetlands work in marshes. Plants grow, they die, they accumulate, bacteria rot them. That forms a food source for an amazing array of species, including many of the insect forms that we see in Clear Lake. So I'm a fan of the lake, and I'm a fan of the organisms that live in it. I think people have to know what to appreciate about Clear Lake and what to accept. We grow up with swimming pool minds. I know I grew up in the city. I expect to drink a beer and jump into deep water. And in a functioning shallow green lake, doesn't work like that. To have the lake in best shape it can be, we need willows, we need tules, we need sedges, we need cottonwoods. We need a border that essentially uses so much of the nutrients coming in from the surrounding hillside that the lake can be in balance. There is a debate that is being settled by current research as to how important the input of nutrients from the outside the lake is relative to the input of nutrients inside the lake. So there's big fancy terms for this. That is outside is called allochthonous, and that is the nutrients coming from inside is autochthonous. And for many years, and I am a person who sees the outside influence as important. That's why I've been working to get the Middle Creek Marsh established to slow down the flow of sediments and nutrients from the outside. But research by UC Davis has shown how very much important the bottom is, how important the in the system autochthonous release is, especially in times of low oxygen concentration. The productivity of the algae, the blue-green algae that I was enthusing about before, at some times that productivity, that organic matter accumulates and its rotting uses up the oxygen. At that point, not only is it bad news for the fish, but it also causes a substantial release of phosphorus and iron from the sediments. So we have something bad for the vertebrates and something bad for the whole system as a whole. And the research is looking at that. So if we zero in on the problem of outside allochthonous input of nutrients and sediment, what we need is more wetlands. And we need places for water to slow down, for sediments to settle, and for the nutrients to be used by an assortment of very, very hungry large plants, willows and tules, cottonwoods. And so this is the importance of finding places where wetlands can be reestablished. Certainly Anderson Marsh, but further upstream in the flow of things in Middle Creek. Middle Creek represents over 40% of the input of water and sediments and nutrients. And so a project that many of us have been pushing for in Middle Creek is the Army Corps of Engineers Middle Creek Restoration. And what will it establish is 1,600 acres of wetland where sediments coming from Scotts and Middle Creek and Clover Creek can do exactly that. The water can settle, it can provide nutrients for fast-growing marshland plants, and it will act as a catch basin. It will not act that way forever, but it will act that way for 50 or more years and act to give us a jump start, a head start on controlling the output of nutrients.
So there's 32 acres of tules out here that get their water only from groundwater coming up from the lake. So the tules are fine, but no fish have access to it. So it's really not a functional ecosystem. So we're going to break the levee in 3 places and then reconnect that to the lake. And we're standing on very damaged old farm road because what happens when Manning overflows, Manning is south of here, and it takes a left turn. And when Manning overflows, it just goes straight and sheet flows across the property to the south, hits our berm and levee and channels down. And it wants to be over there. So in places like this, it goes there. The water goes where it wants to go. So we're going to put swales in this road so that the water will have access out to the tules and then beyond the tules into the lake. So we call it our Restoring the Hydrology Project. And one of the main ways it's going to benefit Clear Lake is by spreading the Manning Creek flow out over close to 50 acres of tules that they no longer flow to. It's going to slow down the water, so sediment, which contains a lot of phosphorus, is going to settle out into the tule bed, and that's going to reduce the incidence of harmful algae blooms, because they depend on the phosphorus that's in the soil. Just because of the nature of the soil in Lake County, the soil's full of phosphorus. So it's going to spread it out, slow it down, sediment it out, and the water that flows into the lake is going to be less nutritious for the green algae.
We're in a highly modified environment. It's taken over 100 years for us to get to this situation. It's taken a lot of effort and a lot of work. There's been a tremendous amount of agricultural development, aggregate mining or gravel mining. These are big operations that have required a lot of capital, and they've definitely had an impact. And for restoration, it's going to take an equal amount of effort, and it's going to take a long time. The one wonderful thing about the environment is if you commit resources to it, it is really resilient, and you can restore habitats and improve species populations. But it takes effort, and it takes effort along the scale of the initial activities that resulted in the impact that reduced the habitat. So we have a lot of work to do, but if we work together and if we collaborate, we can make incredible incredible progress. I also really believe in multi-benefit projects. It's not, we live in our current environment, and in terms of restoration, we want to make aquatic ecosystems better and healthier, but that doesn't always have to come at the expense of our existing land uses that we have. Many of the projects that we work on can benefit both aquatic systems and agricultural land uses at the same time. So there's lots of opportunity for collaboration, and that's the type of work that we really enjoy doing. One thing when you think about restoration and the work that we do is that it takes time. Sometimes you do a restoration project and you see an immediate benefit, the fish come back and use the site immediately. But many of the processes that we're working on in Clear Lake are much bigger, and it's going to take many restoration projects scattered around the entire lake, and it's going to take a long time for those benefits to pay off. And opposed to looking at the time scale of years, we need to think about decades. We need to put in a lot of effort and commit a lot of resources to it, and then we will see benefits, but sometimes it takes a long time for those benefits to occur.
From the State Water Board, we regulate water rights and the use of water in a lot of circumstances throughout California. So we spent a lot of 2023 talking to the tribal representatives, also talking with county representatives and different agencies, both state and federal, to get a better understanding of what was happening in Clear Lake, specifically with response to what was happening to the Clear Lake hitch. We came to the understanding that there was likely some sort of a connection between groundwater and surface water interactions in the area, but it just wasn't clear to us what the impacts were. And what we've done is we've gone out and asked water users within the Clear Lake watershed to provide information about where their groundwater wells are, how much water they use, and the types of water uses they do. What we're trying to determine is how water use is impacting creek flows. So if you have groundwater pumping occurring, it can deplete the amount of water flowing through the creeks. By doing the groundwater surface water study, we're hoping to determine how much water is being taken, and is it being taken by people pulling it directly out of the creeks. What we want to understand is, are the creeks drying prematurely because of water use, or is it just happening because of the natural hydrologic cycle that's occurring in the area? So that's what we hope to determine. And then ideally, once we have that information, we can work with the community and tribal members and water users to identify solutions for that. So once we have a better understanding of what's happening, we can try and come up with management actions.
I think the general public would be surprised to learn how exciting the Clear Lake volcanic field is for geologists. It's spectacularly exposed in many cases. It's young, it's compositionally diverse, it's potentially still active, and so there is a wealth of information to be learned about the Clear Lake volcanic field beyond what we already know, which is quite a bit. And so it's a really exciting place to work as a geologist, and I think if you are a hobby scientist, an incredibly interesting place to live, because everywhere you look, there's a different kind of rock that tells you something different about the history of this volcanic field and potentially the future of it. And what is my favorite thing about Clear Lake? A million things flood into my mind. My favorite thing about Clear Lake is being able to lead a team of people, all of whom are experts in different things, out here and walk around with them, and a rock that I would look at and be like, I don't want to pick up that rock, I'm gonna move on. They will spend the entire day super excited about that rock and what it tells them about the thing that they understand most about volcanic rocks. And so my favorite part about being out here is being able to learn from my team of experts things that I was totally naive to. I mean, that's why we do science, right? Is because we're curious human beings. And so yeah, my favorite thing is just being able to see my team get excited about things that I know nothing about and then learning about it from them.
So when I talk to people about this project, I always ask them do you know where Clear Lake is? And if they say yes, I say, what do you think about the lake? And what they often tell me is that Clear Lake, oh, it's kind of smelly, or, you know, the lake is kind of dirty. And so I use this as an opportunity to launch into all of the amazing work that people around the lake are doing right now. So especially tribes have led the way in monitoring for cyanobacteria, and have really been an amazing example for other tribes and other water quality monitoring nationwide and even internationally, I would say too. And the engagement of the community is really amazing here. I would say I haven't seen any place that has as caring people here. I hear stories of people who grew up here and they used to swim in the lake every day, and they're just devastated that they can't, and they want to do something about it. So for me, that's one of the things that I just love to start talking about in terms of what's going on at Clear Lake. The engagement has just been really amazing and inspiring to see.
As we clean this lake up and make it healthier, I'm really looking forward to a return of an improvement in the native fish, particularly the chi, which is a local native fish unique to Clear Lake, which has been heavily threatened. But talk about collaboration. The state and federal agencies and the tribes and the county and other locals have all gotten together to work diligently to try to save this precious fish that's not just important to the ecology of the lake, but is incredibly important culturally to the tribes in the area. And it's a great example of how when things get bad, people come together.
We can start healing this lake with some of these programs if we just use it from a different avenue as well.
But when I see snow on top of Kanakatai, that's where I know the heaven and earth meet. And that's where, that's why I know this is a breathing, living place where heaven and our earth come together. And so when I'm up there, that's where I say my prayers. That's where I pray for our community, our elders, our children, our next generations to come, so that they have that opportunity to get up there too, because there's a spirit up there that is just infectious. It's hard to describe. I don't think English does the words to describe what it's like up there. But that feeling that you get when you get up there, that's what I want generations to come to feel.
All right, it's coming from the northwest. That's the summer wind. This is from Johnny Mercer. The summer wind comes blowing in northwest of me. It lingers there, and though it seems unfair, blows the gunk to me. But convection's fair, it doesn't care. To you tomorrow, today towards me. Fate's fickle friend, the summer wind. Now the summer winners and the summer losers in the small green farms will shift in time if we redefine the nutrient norms. And every diatom that feels at home is our ally. If it competes in the summer wind. Now what made us think we could swim and not sink with 15% of the native flora in our littoral? Were we that hell-bent? But to rip it out, what was that about? More sediments and more nutrients. More blue-green grist for the summer wind. Now the winter wind and the autumn wind suggest the problem's gone. And it's time to mow and to sow before the storms come on. And every sedge on the edge helps the willow stem the flow to keep water around, you better cover ground. Now like a painted kite, those summer days and nights, they go flying by. And the earth cries, pew, beneath the blue umbrella sky. And the lake goes from blue-green to just obscene, and once more, the leeward shore finds pain and patience in the summer wind. Finds pain and patience in the summer wind. Session in lakes from blue to green. Blue lakes, blue as the sea. For the same reason, almost chlorophyll free. Green lakes, as for your hunch, loaded with pigment, fish can find lunch. Now the greener the water, the thicker the plants, nutrients and sun, production and chance. Energy's transformed in life files thick. You can say it in French, say, oligotrophique. No, a eutrophique. But a blue lake, cut to the quick, is a low energy desert. It's oligotrophic. Blue lakes, new and so clear, are found in mountains. They're colder than milk. Now each lake is a lady who mellows with time, warms up and ages almost like wine. Monitor the changes by noting the hue. Deny her nutrients and she will stay blue. But then nitrogen arrives on the scene. That's when the blue lake starts to turn green. Of phosphorus, if you keep it scarce, that's the trick. Of keeping an emerald mesotrophic. Now phosphorus and there's nitrogen and iron and such, they enliven but people, well, we add too much. Never-ending biomass, what do you think? Gets pushed forward by winds, it rots and then stinks. Blue greens piled on thick, it's all overnourished, it's eutrophic. Where was